Hello everyone, my name is Arsyarifun Nur. I'm from Department of Civil and Environmental Engineering of Lamar University. Now I'd like to share about road classification using convolutional neural network or CNN using TensorFlow and in Python. First, I collected about 1024 images of road using iPhone 8 using square mode. The road images there's two class. First, in the yellow square, road with cracks, and in the red square, road without cracks. All the images were collected in Lamar University campus. The road can be pavement or asphalt, but here we focus on road with crack or road without cracks. So first, we need to import all necessary library into Python. Here I use Spider in Anaconda. You can see all the necessary libraries such as OS, NumPy, Phil, Pandas, and Keras from TensorFlow. I also use Seaborn to make the heat map of confusion matrix. And here, this is my directory, and you need to set your directory. First, the first is image processing. So I resize all the images into 30 by 30. So because the images from the phone's really high resolution, so I need to resize so the process will be faster. And then after that, convert the image into NumPy array using NumPy and normalize the pixel values by dividing the image by 255. So the pixel values between 0 and 1. After that, I combine all the images into one dataset, let's say X, and then give the label 1 for crack images and 0 for no crack images. Next, the dataset was split into training, validation, and testing dataset with ratio about 50% for training, 20% for validation, and 30% for testing dataset. So the splitting also use the random function, so the dataset will be randomized, and you can see the shape of each dataset. For example, training data shape 501 for the images, and 300 by 300 means the dimension of the image, and 3 means the color channel of the image, which means RGB channels, red, green, blue channels. Next is creating the architecture of the CNN model. Here I follow the architecture from the TensorFlow tutorials for CNN classification. First I use the sequential and then edit the convolutional 2D with 32 nodes and activation ReLU, and then another convolutional 2D with 64 node, also the next layer 64 node, using max pooling with filter 2 by 2. And then the flatten layers to flatten the images into 1 dimension. And then the dense layers with 128 nodes, same using ReLU activation. And the last layer is dense layers with 1 nodes or 1 output. So because the output from our class is correct or no correct. So only one output with activation of sigmoid. And you can see the summary of the model in the left side. Next is compiling the models. Here, Adam optimizer is used with binary cross entropy loss function, and then fit the model into training dataset with epochs of 100 and validate with validation data. You can see the graph show the decrease of loss with the increase of epochs from 1 to near to 0 in the last epochs or 100 epochs, which means that the fittings process really well. And then we evaluate the models using testing dataset. Here we can see that the accuracy of the models about 86% or 0.8636. And the graph show the accuracy using testing dataset and validation accuracy. The accuracy increase along with the increase or epoch of the accuracy increase along with the increase of epochs. And then we also use the confusion matrix to show the result of the evaluation using testing dataset. We can see that the cracks. So the models predicted the labels or the result using testing dataset. So this is the confusion matrix show that the predicted no crack with actual no cracks about 154 and predicted crack with actual crack about 112, larger than the errors such as predicted crack with actual no crack about 15 and predicted no crack with actual crack of 27. So that is the errors or misclassification. Comparing the misclassification and true classification, the models show a good performance. And here is the reference I used to develop the models from the TensorFlow website, Google website, and Geeks4Geeks website. So after all, the models, the CNN, convolutional neural network models, can be used to classify the roads with crack or no cracks with a high accuracy, about 86%. The more input or the more training data for the models will increase the accuracy of the models. So for the future, I will try to increase the input image, so the accuracy will increase. That's all for me. Thank you very much.